Okay, and good morning to everyone. And that was the Reverend Al Green. And So Beautiful, is that what the title? You are so beautiful. There we go. Algebra is so beautiful. I appreciate the modification of the title there. Okay, one of the things that has been asked, and this is, I think I learned a better way of doing this. Now, wait a minute. This is, yesterday we did 3-4, correct? 3-3. Okay, let me try something here. Okay, I figured out a nice way of doing this. This is to try to answer a question that Emily asked. So what I'm going to do is come down here, and these are the 24 questions, I believe. So let's go to the document cam now. I'll see if this is an agreement. So these are the questions that were in 3-3, and they started with 1, 4, 7, 10, 13, 16, 19. Is that correct?
Yes.
Am I correct there?
Yes.
And go down to 22. No, hold on. Let's see. Should I go across? I guess that's the way I should have done this, is reading it. Starting across that we had 1, 2, 3. No, that's still not making sense the way this is. What are your first questions? Let me ask you. That you were supposed to do. What number? No. Just the numbers. Okay, coming off there for a minute. Okay, Michael, what numbers do you have? Do you have them written down that you...
Yeah, 1 through 24.
Yeah, I have 1 through 24 too.
Just 1 through 24? Okay, so that is what we're seeing here as we come back to the screen. So Emily, your answer is 1 through 24 all on 3-3. So you did the odd ones, so you'll want to, we can come off there now. So on 3-3, we had 1 through 24 all. Okay, we're on 3-3 we're talking about. 177. And that didn't include, I didn't include anything beyond that?
Well,
You heard.
it's like, they're talking about online, of course, because there's 24 problems.
Yeah, but not 1 through 24.
Yeah, 1 through 20.
No, I'm not making the statement the way I want.
Yeah, have every
Yeah, it's not sequentially doing 1, 2, 3, 4 from the text. That's what I was trying to set up. So that's a confusion on my part in asking the question. Yes, Isaac.
I had one question on the homework.
Well, we're going to come back to that in a moment. I was trying to answer Emily's question, and that is not going to do it the way I was wanting, so I'll try to get back to that in a different way. So let's see if we can answer the question. What is going on here is I did not take time last night to go ahead and put those on the website, and that's what I was trying to do. We'll have to pick that up. Maybe I can get the computer to work on that while we're talking about other things. There are some questions. So, Michael, let's look first at the one that the computer did not seem to respond to in terms of the correct answer. Do you want to read the problem to me as I go to the board? Okay, let me get a couple pieces of chalk here. Okay.
It's parentheses.
Okay.
Minus 3a cubed.
Minus 3a cubed.
Minus 3a squared.
Minus 3a squared.
Plus 9a.
Plus 9a.
Plus 8.
Plus 8.
Plus then minus bracket or
Parentheses, okay. So what I'm going to do is just put this down here, if you don't mind, for the moment. Okay, in parentheses,
minus 3a cubed.
3a cubed,
Plus 8a squared.
8a squared,
Plus 12a.
plus 12a,
Minus 3.
minus 3. That's it? And so I simply want to subtract. So if we think of this as, I'm again going to disappear from camera for a moment to get a straight edge, come back. If you look at it stacking them, and this, of course, was a question of what approach are you going to use. What you could do now is simply come across here and change each of these signs. And when I do that, the negative 3a cubed and plus 3a cubed will go to 0. I have a negative 3a squared and negative 8a squared, which is a negative 11a squared. Then I have a negative 3a and a positive 11, correct?
Yes.
And you're saying when you entered that into the computer, it just did not agree with you. Okay, and again, the problems don't have an answer for that other than note it. Any questions there?
The negative 3a squared plus 8a squared should be negative 5a squared. Negative 3 plus 8.
This was changed to a minus sign because we were subtracting.
Oh, I see.
And so I had a negative 3a squared and a negative 8a squared, okay, which went to a negative 11. So again, evidently there are places, just note it, don't belabor it if you're fairly comfortable. I guess this is a case where you went on through and they showed the answer and it was the same answer you had, but it wouldn't accept it. And I don't know if it has to do with spacing. I have no idea at the moment why that's happening. Loretta, any insight on your part on this, why it's not? Other than you just call in and say, okay. Yes, question.
I had one like that, and it wanted me to put just a cubed, but then I did it on the next one, which was an x, and it said it was wrong, it didn't want anything. So it's just kind of touchy.
When you say,
You see how you didn't put anything in the beginning?
so I had 0 times negative a cubed?
Right, and it just wanted a cubed. For some.
Okay, which couldn't be because, okay, I see what you're saying. But then when it comes up with the answer that you have, just write it off as, okay, computer glitch, note the problem, and maybe call in. Yes, Lorena?
Or Pearson's representatives on campus at all times.
Really?
It's four of them here on campus at all times, and you can call them if you want to sit with them for an hour and do it with them so they can see the time.
Who do they, do you have a number you can call?
I have Anna Kear's number. She was the person who did that stuff for NJC, so I can call her and ask her for representative.
She's from.
Okay, we'll do that.
My writing
Okay, so
on
have a
campus.
representative from Pearson on campus tomorrow during tutoring. Maybe that'll help. It's not going to help what you went through just now, but we'll try to minimize the frustration. Yes, Sandra?
Also, I have a 1-800 number from Pearson if people are doing it at home and they're having difficulty, they'll walk you through.
Okay, so Sandra has an 800 number that you can call from home to walk you through if there's a problem that you're having at home. And certainly you can call from school. 800 number if you're on a cell phone. You may, depending on how your call plan is, could or could not be a problem. Isaac,
All right.
you've got a problem.
Yes.
Oh, go with it.
Wrote down. The width of a rectangle is 4x minus 6 feet, and the length of 2x plus 8 feet.
So I have a rectangle.
Yes.
So let me draw a rectangle. So here we have a case where we have a rectangle with some dimensions that are given in terms of expressions. And my guess is maybe I'm finding perimeter? Nope, okay.
Yeah, you find perimeter, but,
Well, let's take the sides. What's the length?
the length is 2x plus 8.
2x plus 8. The width?
The width is 4x minus 6 feet.
4x minus 6, and feet in both cases.
Yeah.
And then what am I supposed to find?
Write a polynomial, whatever.
Polynomial.
Polynomial.
Yes, that
They like
one.
polynomial.
Yes. Then represent the perimeter.
Okay, so I want the perimeter as a polynomial.
Yes.
There you go.
Okay, so the simplest way is remember that perimeter is 2L plus 2W. So 2L would be 2 times the quantity, 2x plus 8. Twice the width would be 2 times 4x minus 6. But then I'm supposed to expand that, or I could have written each of these twice and added them. So I have 4x plus 16 plus 8x minus 12. So I've simply used the distributive property in doing that. So I have 12x plus 4. That's my polynomial. Okay?
Yeah, that was easy.
Is there a further question? Okay. Anybody else? Okay, Kim.
Two, but this one, 21. It's write an expression for the perimeter in the simplest form. It gives you a triangle.
Okay, just a minute. 21 must not be from the book.
No.
This is,
From the
oh,
computer.
I was looking at 21 there and it wasn't. Okay.
Right.
Again, give me your
Write an expression for the perimeter in simplest form. It gives you a triangle.
triangle. Is it a right triangle?
No.
Just a general,
Pyramid.
what?
Just a triangle.
A pyramid? Okay, this is my pyramid?
It's wider on the bottom.
I don't think that matters.
Okay, but a generic pyramid, wider in the bottom than what I have, but this will go.
On the left there you have an X.
Here's an X.
Yes, and you have a Y. And at the bottom you have a Z. And then it gives you X equals N plus 33.
X equals M.
N,
N as in Nancy.
yes,
N what?
plus 33.
Plus 33.
Then we have Y equals N plus 88.
Okay.
And we have Z equals 4N plus 85.
Now is it parentheses?
No,
4N
plus 85.
plus 85, and I'm supposed to find what?
Perimeter,
Perimeter, so that would mean add X, Y, and Z.
yes.
So since I have these lined up, what do I have to remember about that N?
Combine like terms.
What's missing in front of that N?
A 1.
One.
The understood one, the noceum.
So 6 and
Oh.
1 and 1, and the minute you put those in, does it become clear that you want
So I
6
just-
in?
Yeah, it does.
And then, of course, here we have what? A 171, so 204?
206.
5 and 8 is 13.
Plus 3.
And
Plus
6.
3.
Okay, where did I end up wrong in that? Because I took this and got, I should have had 173, 206. Okay. We okay?
Yep. And it makes sense now.
Just by the missing ones.
Uh-huh.
And again, that's where that missing one helps, either as an exponent or as a coefficient. Anybody else in that? We're okay? Good. I feel better after all of our frustration of yesterday. Well, we're going to now multiply polynomials. Okay. Lots of things going on today. Lots of things. First, just a very simple problem. Two to the third times 2 to the second. We could sit there and say that's 2 times 2 times 2 times 2 times 2. And note that we have 5 2's multiplied together. Or we can say it's 3 of them plus 2 of them, so that's 2 to the 5th. Now, I'm hoping that that works for you. Question? What?
Would that be the intermediate step?
That would be an intermediate step, yes. Thank you. It's based on this statement. Instead of just a 2, that's going to work for any number, agreed? So what is oftentimes done is say you have a to the m times a to the n, and so that, we argue, is a to the m plus n. And if that's all there was to it, we would never have a problem. Wait a minute. There is a coefficient of 1 in each case, and 1 times 1 is 1, and so I get 1. Well, that wasn't a coefficient, that was the base. Right? So I only write the base once. Now, let me ask you this. What is 2 to the second to the third? Well, it's 2 to the second times 2 to the second times 2 to the second. So I could argue that that's 2 to the 2 plus 2 plus 2, which is 2 to the 6th. Or just say 2 times 3 is 6. So I could have had an intermediate step and say it's 2 to the 2 times 3. Or to put it in a more general term, a to the m all to the n is a to the mn multiplied together. Now again, if we just had this statement, there wouldn't be confusion. But now we're adding here, multiplying here. What's different about those? Here I had something to a power times the same base to another power. Here I have this inside, which is to a power, but that whole thing is to another power. The distinction between these two, you're just going to have to more or less memorize. Or you end up writing down 2 to the second times 2 to the second times 2 to the second, because it was to the third power, and that may help you. That's the first observation. Now we already know, and I'm pulling a lot of things together here today, the distributive property says if you have A times B plus C, this is equal to what? A times B plus A times C, correct? But I could extend that. If I have A times B plus C plus D, that's AB plus AC plus AD ad nauseum. Doesn't matter how much garbage I have in that parentheses, I just keep distributing it, correct? Okay, Michael.
All right. If you were to, inside of the parentheses, the 2 squared,
Okay, here.
okay, if you were to square it up and put a 4 there.
Oh, you mean put a 4 here. So do what's inside first. So I'd have 4, and that's 4 to the third,
And it's the same answer.
which is 64.
So it'll come out the same way, right?
And 2 to the sixth is 64. Yes, we'll get the same answer. But I'm trying to simply write it as the base to the new exponent. Now, you couldn't play that game here, because there's no way you can simplify a to the m, because you don't know what a is, and you don't know what m is. Okay. Now, putting these together, let's say I have 2x times 3x squared plus 5x minus 2. Taking the same idea, I can multiply a monomial through this polynomial using what? The distributive property. So if I do that, now, this is where I multiply the coefficients, because 2 times 3 is 6. Kim, I'm missing an exponent here that's understood, so that's really x to the first. So I would encourage you for the moment to write the exponent that's missing. Now I'm going to show you an intermediate step that I don't want you to be getting hung up on forever. That is, this is really 2x to the first times 3x squared plus 2x to the first times 5x plus 2x to the first times a negative 2. Intermediate step. A lot of garbage, right? Distributing this outside through each of 3 parts inside. This was technically plus a minus 2. Hence the minus 2 and the plus sign here. Kim?
They don't have to match, you know?
No, anything out here is distributed through whatever is inside. Nothing matches here.
Okay.
It could be totally, otherwise this could be a 2y.
And they could be initially times with a 3x.
2y times 3x squared, then I would have 6y x squared.
You can do it even though the variables are
Yes, even though the variables are different. Michael?
Where are you getting the 2x to the first?
I had 2x to the first outside multiplied by 3x squared.
No.
Got this mess here,
Okay.
and I multiply it here, and multiply it there.
Oh,
That help?
okay. Yeah. Okay. Yeah.
Now, what happens next? 6 And then x to the first times x to the second is x to the 1 plus 2. Because I add the exponents. X to the first times x to the second is x to the 1 plus 2. Okay, I'm going to rotate, Debbie, and we're going to come back here to this for a moment. We said a to the m times a to the n is a to the m plus n. If this is 1 and this is 2, 1 plus 2. Back to here, okay?
We're gonna add it, and that's in the parentheses.
Well, we're going to first try to simplify each product. This is a product here. I want to simplify it. So that means I have an x times an x times an x, which is x cubed. So this becomes 6x to the third plus 2 times 5 is 10. And again, let me erase that parentheses here and put in the missing what? 1. So that's 10x to the what? 1 plus 1. And then I have minus 4x to the 1. So this is going to be plus 10x to the second minus 4x to the first. Sandra.
Is that a property or the A?
Okay, coming back over here, Debbie. Yes, these are two properties that we're going to look at with exponents, yes. Okay? We do another one? Okay, coming back to here now. Do I leave this like I have here? For the moment, yes. For the moment. But what you may note, this is going into the next section. There's an x that's in every one of those. So I could pull that x out. And each of these are even. So I could pull a 2 out. So I could factor out 2x and have something left in parentheses. That's where we're headed. Not today. But that's the answer to your question. Was that a hand going up or not? Richie? Okay. We're ready to go on to another problem? Okay, let me come back center for a moment. This is in section 3-4. And I'm going to try to go to where the problems are just to show you what we've just done. I'm looking at problems like this at the top of page 191. Okay, and let me take a moment here, Debbie, just to, why don't you go to the top of page 91 with the document cam, and then I'll do something I have to do here for a moment. Okay, I wanted to do that. Why did it? Okay. Now, looking, if you will, please, at something like number 62. Okay, let me see if I can get that a little bit tighter. Now, here's number 62 in the book. I'll try to bring that tighter yet. There we go. Sorry for the bouncing. But look what's done here and see if that makes sense. You can see the answer that's done for you. The answer's at the end. But I'm going to take this negative t to the third times 3t to the second. What would help if I put in front of this t to the third? Maybe a negative 1 instead of just the negative sign? Do you see why you get negative 3t to the fifth? Okay, Kim, take a look here. What I've got, make sure this is making sense for you. I have a negative 1t to the third times 3t to the second, so that t to the third times t to the second gives you t to the fifth. And you're going to have a negative 3. Okay, now a negative t to the third times a positive t will give you a negative. And there's 3 to the first. This is the missing t to the first. Hence t to the fourth. Then the negative times a negative is going to give you a positive 8. t to the third. Does that make sense to you?
No.
Where are you lost?
All of it.
Let's go back to the board here. I had said, and I messed that up, I said this was AB plus AC plus AD, correct?
Yeah.
We said we could take whatever's outside and distribute it across these three terms, multiplying. Fair? Okay, now let's come back to the book.
Oh, no. We're just doing that inside the book. Oh, okay.
The negative t cubed is your A. Here's your B, C, and D. So I'm just make arrows. One of them, two of them, three of them. Does that make sense now?
It does.
Good.
Distribute.
Distribute, yes, distribute it across. Draw the arrows. A problem like 47, again, I'll show you the problem and the answer. Let's look at this one. 47. I've got a 5, so I'm going to distribute it across, and does it make sense that you're going to get 15x and minus 35? Any question there? Good, then we can mess it up. Now, I'm going to go a little bit further, but I'm going to have to do it with the other boards. So the kind of problem I want to look at next is illustrated in this problem, these two problems right here. There are three of them in a row, but I think we can cut to the document cam this kind of mess. That's where I'm headed. And again, let me just write one of these down. It's x plus 4 times x plus 2. Now, remember, A times B plus C is AB plus AC, correct? Treat this as A, this is B, and this is C. Now, if you understand what I've set up here, then this A is multiplied by X. Then that same A is multiplied by 2. Commutative property. Rewrite that as x times x plus 4. Rewrite this as 2 times x plus 4 by commutativity. Reapply the distributive property. This is x to the first, x to the first. X to the first times x to the first is x squared. Then plus 4x to the first. Then plus 2x to the first plus 8. Combine x squared plus 6x plus 8. Multiplying two binomials together. Now sometimes you will find a problem done this way, where you put one below the other and then multiply like you would in regular arithmetic. Say 2 times 4 is 8. 2 times x is 2x. X times 4 is 4x. X times x is x squared. And you get x squared plus 6x plus 8. It's done sometimes. I occasionally go to something like that. Jessica.
I remember doing it where you times x and then x times 2. It's kind of the same thing that you did, and then do the 4 times x times the 4 times.
Otherwise, you took this x times x plus 2 and then took the 4 times x plus 2. You could. We, in practice, don't do either. We observe that what you're really doing, and I'm going to now write these up here. Now note we ended up with x times x, correct? So we multiplied these two together. Then we did the outers. 2x. Then we did the inners. 4x. And then we did the last. So if you take the first, x squared, plus the outer product, 2x, plus the inner product, 4x, plus the last, you get 8. That is x squared plus 6x plus 8. And that is known as FOIL. Aluminum. FOIL. First, outer, inner, last. Okay. The first of each binomial, the outers, the inners, the last. So first, outer, inner, last. Pom-poms help. Okay, so again, visually. First, outer, inner, last. And that's exactly what you're doing. Let's look at the document cam again. So I have an m minus 3 times an m plus 5. Now notice the signs are different here. But still, what's product of the first? M squared. There's an m to the first, m to the first. So m squared. Okay, what is the outers? Going as far out as you can. 15. Or 5m, sorry. I was doing the last. 5m. Inners, negative 3m. And finally, the last, negative 15. Now, what do? M squared plus 2m minus 15 using FOIL.
Is there another way to do this FOIL?
No, as FOIL, this is the only way for FOIL. The alternative to FOIL, as we back up, this was the alternative using the distributive property twice. This was stacking them and multiplying. So you had 3 alternatives. I expect you to know them all. No, FOIL may seem confusing, but it's really what's going to allow you to do these in your head. And so I would, my typical assignment is give you 100 of these and expect you to do them in a very short period of time.
So you want us to know
All these 3 techniques, yes. Okay? So let's just create some problem a little bit more complicated. 3x plus 2 times 5x minus 1. Okay? Are we ready? Give me the first just in your head. You are adding, not multiplying. Okay? So you want to multiply, not add. Okay, so you're multiplying the first. So how about 15x squared? Agreed? Now, I didn't put the 1 here and the 1 here that are understood, because typically you won't. You can't afford to with the time frames and the pressure that you'll be expected to do problems like this. Well, what are your outer products, or what is the outer product? Minus 3x technically to the first. The inner product? 10x to the first. The last? Negative 2. Finally, one more step to happiness. 15x squared plus 7x to the first minus 2. Michael?
the FOIL technique, would that work with the bigger problem? Like if there was more...
Binomials times binomials only.
Okay.
So FOIL with binomials times binomials. Now let me come back to why this is an important process to memorize as a technique as opposed to another approach. So far we're going this direction, right? We are going to spend a lot of your lifetime, and I'll be with you in a minute, we're going to spend a lot of your lifetime going in this direction, called factoring. Start with this trinomial and give me a product of two binomials that will give you that. Well, if I gave you, let me come back and give a different one. Let's say I took this one down here. So far, all I've done is write the product of two binomials. It's an expression. I try to simplify it to a polynomial. But we are going to put a condition on such products. So if, big if, m squared plus 2m minus 15 was equal to 0. That was my request. Find m. Solve for m. Same statement. Okay? So if I come across here and I know that I can write this as m minus 3, helps if I get my head in gear before I write. If I can write this mess, this trinomial, this way, I'm home free. Why? If either of these are 0, the product's 0. So once I take this and write it as a product of two binomials, I can look at that and say, wow, m equals 3 works. M equals minus 5 works, and suddenly I have m is equal to 3 or m equals minus 5, and I've solved an equation. We use this as a technique. Start with the trinomial equal to 0, write it as a product equal to 0, and you immediately have your solutions. So we do have to start at the bottom and go up. Right now, all we're trying to do is we come up here a little bit higher now. All we're doing here is say, start with this product of two binomials and get me the trinomial. The analogy in arithmetic. 5 times 7 is 35. You memorized that. Then I say, okay, I've got 35. What are the factors? You work backwards and say 5 times 7. I tell you I have 12. Write it as a product of prime factors. 2 times 2 times 3. That's what we did in prime factoring. Okay? Here is a trinomial. I want to write it as a product of two binomials so I can solve problems like this. That's the idea. Let's go back to the document cam for a moment, Debbie. You should be able to look at one of these now and do it in your head and write the answer. Let's try it. Number 69. Just write the answer. I only want 3 things written down in your answer. Do it in your head. You should be done. That's how fast it should be done. Look at it one more time. Do first, outer, inner, last, and then combine them in your head and write your answer. The 69th problem, the last one on the screen. Oh, 65. Do that in your head. We just did it, but 69 is more fun because we haven't done it yet. Do it in your head. First, outer, inner, last. Try doing it in your head. Yes, you can. Just look at it and do it. Y times y should give you what? Y squared. Okay. Then you have a negative 8y and a positive 1y. So what's 1 and negative 8? Negative 7y. Okay, what's your last? Negative 8. Whether you do inner first, then outer, or outer, then inner, since you're adding, will not make a difference. So you have 1y outer, negative 8y inner. That's negative 7y. True? So you're going to have y squared minus 7y minus 8 in your head. Problem that simple you should be able to do in your head. Let's try one a little less simple. Okay, let's try 70. In your head again. Got it? Number 70. Work at it, doing them in your head. Fight it. No intermediate step in a minute, just in your head. You should have u squared, coming back to it, my version of u2, u squared, then negative 9u, that was the outers, 4u in the center. 9 negative, 4 positive, negative 5u, minus 36. Practice them. The next one, 72. Harder to do, but let's try it. Just write your answer. 5t times 3t. Write it down. As you do it, write down the parts. 3t times 5t, what do you get? 15t squared. Okay, outer. You have 5t times 1, which is 5t. Negative 12t. So what's 5 minus 12? Negative 7t minus 4. Done. Okay. Just do a few hundred of those. Okay, new wrinkle. This time, we're going to introduce something from English, it sounds like. There's the key word, the conjugate. To conjugate verbs doesn't have anything to do with what we're doing in mathematics. Okay, let's look at this problem. X plus 2 times x minus 2. Okay, let's go for FOIL. Not 2x. Come on. X to the first times x to the first. You're multiplying them, you're not adding them. X squared. Okay, the outer. The outer. Negative 2x. The inner. 2x. The last. Negative 4. Now, Isaac's correct. The negative 2x, the positive 2x go to 0, and I get x squared minus 4. If I give you a plus b, the conjugate of a plus b is a minus b. You trade in the sum for the difference. So a minus b is the conjugate of a plus b. Anytime I have a problem like this, the answer is a squared minus b squared. That fast. So if I give you 3x plus 4 times 3x minus 4, what's your answer going to be? 9x squared, because this was x to the first, so square the 3x. 9x squared, put a minus sign, 16, done. Can you do it with FOIL? Yes. Do you want to? No. You need to memorize that this product of a binomial times its conjugate is just the difference of the squares of those two terms. Action. Let's do another one. 11x plus 13. 11x minus 13. What's the answer? 121x squared. You've got to have that x in there, which is the same as this. Then minus what? Not 196, 169, which is 13 squared. Leave that on the board. break for a moment to an easier problem, just to make sure that we can handle it. This is back to make sure you can do the easy stuff before you start messing with the tough stuff. 23. Write the answer down for me on paper. No intermediate steps, just write me the answer. Letting you stare at it for a moment. What's the coefficient going to be? No, not -9. Final answer. Final answer, I'll slide that over. There. Hot spot and all. What's your final coefficient? Final coefficient. Still have not heard the correct answer. Yes. Number 23. Okay. Coefficients. 3 times -3 is -9 times 4. -36. You aren't squaring this 3, only the m. It's 3 times 3 times 4. 9 times 4 is 36. You had a negative here, hence -36. Now, it's m to the what? First, second, 1 plus 2 plus 1, or otherwise known as -36m to the fourth. I'm getting that look from Marisol this time, okay? Let's look at another one. Okay, 22. Multiply your coefficients together first. No distributive property here. What do you get for the coefficient?
30.
2 times 5 is 10. So I'm going to multiply the 2 and the 5, getting 10, times the 3 is 30. Then a to the what?
Fourth.
To the fourth power. Because that's a to the first. A to the first. Add the exponents. Right below it. Help if I get the whole thing there. Okay? 25. Coefficient. Good. 60. Positive 60. Because I have a -5 times the -4. So that's a positive 60. Y to the what? Y to the 9th. Add the exponents on y. I have y to the 4th. Added to a 3 is 7. Added to a 2 is 9. We've got it? Marisol? What's the question? So I can have something I can answer as we come off there.
I just don't, like, I know how you got the answer.
But what?
I don't know why you did that with this one and not the other ones.
Going to the sideboard again. Let's leave this one up here so we can just stare at it so I can come back to it. There is a difference between having minus signs and plus signs in the problem. So if I have x to the first times x to the second times x to the fourth, these are always multiplied, correct? Are you comfortable with the fact that that would be x to the 1 plus 2 plus 4? You're okay there? Okay, now, if I say I have 2x to the first, 3x to the second, and 5x to the fourth, I can switch those back and forth because of commutativity and associativity. So I can rearrange this so it's 2 times 3 times 5. Just like in prime factoring, you could mix these around. 3 times 2 times 5. 5 times 2 times 3. 5 times 3 times 2. Your choice. And I still have what? X to the first, x to the second, x to the fourth. I can rearrange a product any way I want. Now, how do you find 2 times 3 times 5? Just multiply them? So that would become 30. And here I add the exponents and get 7. Is that okay? Now, let me change that and say I have x plus 2 times x plus 3. These are no longer coefficients. The coefficient here, if I wanted, I could make this like 5x plus 2, and maybe make this 2x plus 3, but I have plus signs between here. So I can't just say 5 times 2 times 2 times 3, because these are additions in between. And the distributive property says, in essence, I've got to take all this garbage and multiply it by 2x, all this garbage and multiply it by 3, then do it one more time, or just take 5x times 2x, 10x squared, take the outers, which will give me 15x, take the inners, which will give me 4x, the last, which is 6, and simplify. And what I'm wanting you to see is the difference between these two problems. And that's where I sense you're having trouble seeing the difference between these two. Is that correct? Yeah, okay. Let me come back to the document camp.
Those are the same problems, don't they?
Okay, back to here. These are not the same problems. The one on the top is different from the bottom. I'm trying to contrast them. This was the product of two binomials. This is the product of three monomials. With monomials, I can write it in factored form and just rearrange the factors any way I want. Okay, let's leave that there for a moment. Okay, I'm watching my time for what I still have to do. Michael, question.
Can you write a problem like you did above, but can you do it so you would be able to do it like on the bottom?
No, you can't. You can't change one to the other.
No.
Question that Michael's asking, where let's come back to the sideboard where I had the one on the top part of the screen, which is the product of three monomials. I cannot write it as a product of binomials.
What if you have 4?
If I have 4 monomials, still cannot do it. Cannot be done. Okay, let's come down to another problem, a little bit easier, but make sure it makes sense to you. This one, 34. I have minus 3t to the 7th all to the 3rd. Minus 3t to the 7th all to the 3rd. Now what you have to do, perhaps to make sense out of this, okay, is take your minus 3. Okay, I'm going to do it up here. This is number, what problem is it? 34, thank you. 34, I have minus 3t to the 7th all to the 3rd. Okay, first thing I would do is put a 1 here. Okay, so the minus in front to the 3rd power means I'm going to have a negative. So a negative 3 to 1 times 3 is 3. T to the 7 times 3 is 21. So that's negative 27. And I didn't write the negative sign after saying it. That is negative 27 t to the 21st power. That is a place where you can get trapped a little bit. Okay, leaving that there. So again, as I look at the document cam, okay, and I look at what I have here, this negative 3, you could think of it being in parentheses itself. So negative 3 to the 3rd is negative 27. Remember my rule, t to the 7th to the 3rd, you multiply the exponent. Okay, I'm not going to take camera 2 there. Bring camera 2 back to the a to the m to the n, if you would please, Debbie, in the front board. These two are what you have to keep in your head. These two. A to the m to the n, back to the document cam. T to the 7th, so t to the 7th to the 3rd. T to the 3 times 7. Okay? One more problem. And there is On this, some easy, some not so easy. Let's look at 101. Hint. Multiply 2x plus 3 times x plus 1 using FOIL. That'll give you a trinomial. Then multiply negative x squared times the 3 different parts of your trinomial. That is the simplest way to do 101 and 103. By the way, 103 is a freebie. What do you see? A binomial and its conjugate. This one's a bear. You're going to have to use the distributive property, this garbage in front times each of 3 terms. Okay, you've got a long assignment. I'm going to have to close here because I have about a minute and a half, 2 minutes before we have to be done. This is a very time-consuming assignment, about twice as difficult as last night's, would be my guess. You will have to pay your dues on this. No way out. So Debbie, as we go back to